Alright, in this lesson we'll talk about selecting and extracting rows from a data frame with a date-time index. And as we'll see, the process is no different than if our index consisted of strings or numbers as it typically does. Basically the same old familiar methods, loc, iloc, and ix all apply. So let's begin by executing our code to load our data reader data frame with information for Microsoft's stocks. And let's begin with the loc method in the cell below. So I'm going to call .loc on stocks. As a reminder, these three methods all take square brackets instead of parentheses. They're one of the rare exceptions in pandas. And the loc method extracts a row based on an index label. So in this case, our labels are date times, so we can give a date as a string. So for example, if I want to pull 2014, March 4th, it's going to return to us a series where the index labels are the column names from our data frame. You can see them represented right here, and the values are the values for that row. We also have the familiar iloc method, which is based on index position instead of index label. So in this data frame, our very first row has an index position of 0. In the next one, we have an index position of 1, and so on. So if we wanted, let's say, the index position of 300, which would be the 301st row in our data frame, there is that information. We can see that the date is March 15th, 2011. And of course, we also have the ix method, which is my preferred favorite because it sort of acts as a catch-all. You can either give it index labels or index positions. So for example, if I want the same thing as the loc method, I'll put in the exact same date. It's going to give me the exact same result. But with ix, I can also supply an index position, such as we did to the iloc method, and we're going to get the same March 15th result. Now, with all of these methods, if we put in something that does not exist, we're going to run into an error. So for example, if I put in the 1st of 2016, which can either be something like a Saturday or a Sunday or something like a holiday in this case, basically any day of the week that the stock market is not open, then we're going to get an error. And it's going to tell us at the bottom that that value does not exist in our data frame. Let's take a look here. Scroll down here. You can see it says key error. This key was basically not found in our data frame. So in addition to all this stuff, the ix, loc, and iloc, all of the familiar operations for extracting multiple values work. So if we want something like sequential dates, we can do something like stocks.loc. And let's say we want to begin at the 1st of October 2013 and pull all the way to the 7th of October 2013. So we basically have a week-long range. If I do something like that, you can see it's going to pull in those values. It's also smart enough to realize, of course, this, even though these are dates, it's looking at them as index labels. So even though we don't have values for 5 or 6 among the days in October, it's going to skip and go right to this end date, which is October 7th. It's looking at it basically like a regular string label, so it's just running until it finds those values. And the same thing would apply for ix, so I'm just going to copy this exact thing. You can use whatever method you prefer. Some people, I think, will argue over which ones are more efficient. I personally prefer ix just because it's the best kind of error-proof one to work with. So let's conclude this lesson with an example of pulling non-sequential dates. So let's say I want to pull the stock price of Microsoft for every occurrence of my birthday. So I was born on April 12th, so I want to see what the stock price was on April 12th of every year. So what I can do is actually use the date range method that we introduced a few lessons ago, and I can use it to create a date range of my birthdays. So basically April 12th from the year I was born, and then all the way to present day. And it'll have that DateTime index, and then I can use our familiar isIn method to see whether we can compare the values in this data frame with those values in my birthday dates list, and then extract those rows that match. So let's put this into practice. I'm going to call the dateRange method, pd.dateRange. As you may recall, we have a start and end parameter and also periods, but in this case we don't need it. So I'm going to begin by putting start equals my birthday, which is April 12th, 1991. And for the end, I'm going to put the end of next year, 2017, 12/31. And of course, we're going to need that frequency parameter. And there is that A option for annual, but unfortunately that looks at the last day of each year. We're going to need something a little bit custom here, and we'll dive into this a little bit more later. But I'm going to do pd.dateOffset and open my parentheses here because this is a method, and I'm going to give it the argument years equals 1. And the syntax, of course, will take some time to get used to, but basically all of this is saying is pull all the years, separate all the times rather, by 1 year. Make each frequency, make each interval, make each distance 1 year, starting from 1991 and April 12th to the end of 2017. And we can see here that I'm going to pull all of my birthdays across 1991, 1992, 93, all the way up until 2017, which is the last occurrence. So you can see we've created a date time index of all of my birthdays. I'm going to store this in a variable called birthdays. What I then need to do is compare my values, or rather my index label values, in my stocks data frame. So there's stocks, there's my index. And on this one, I want to call my isIn method, which is available to us. And as a reminder, that's going to give me a Boolean series of trues and falses. And what I'm going to pass in here is my date time index of my birthdays. So what it's going to do is it's going to loop through every value in my index, and it's going to check whether that date exists in my birthday's date time index. If it does, it's going to give me true, and if it doesn't, it's going to give me false. So when I execute this, we're going to get essentially an array instead of a series, but all of these operations are still valid. So now that I have my array, I'm going to store it in a variable called mask. And now if I do stocks and I give it, let's say, loc, and pass mask, you can see that it's going to pull in the stock information for my birthdays. So we can see since our data frame begins in 2010, there is a valid day here when the stock market was open on the 12th, and it's going to pull that in. You can see that 2014 and 2015, the stock market must have been closed that day because those days are not present, and there we conclude with 2016. I don't actually believe we need the loc method. We can just use the regular bracket extraction, but again, that's going to create a separate data frame, and loc is better if you want to modify the values in place. You can use either one. But basically what we've done here is just compare our date time index values within my stocks data frame with our birthdays date time index of 25 or so dates consisting of my birthday. So that's how we can extract non-sequential separated stocks based on something like a condition. So that's a quick introduction to extracting one row or multiple rows as well as sequential rows in a date time index data frame. And in the next lesson, we'll start looking into some more attributes that are available on our timestamp object.